rules as protocol. Simply, protocol is a rule because this protocol determines what is communicated in the network, how it is communicated in the network, and when it is communicated. In the previous lecture, we have seen there are 5 elements of a protocol. Let us just recapture all the 5 elements. A protocol deals with message encoding, message formatting and encapsulation, message timing, message size, and message delivery options. Now we will see what is message encoding. Let Tom be the user. Now Tom wants something from Amazon.com. He opens the browser and gives the request to Amazon.com. And Amazon.com responds back with what Tom is needed. If we observe, this computer, that is Tom's computer, is connected with a wired medium. The transmission medium here is wired medium. This transmission medium is also called as a link. This computer converts the data into signals and sends the signal on the transmission medium, which is the cable here. In case, if Tom wants to access same Amazon.com, but not with a computer, now with a smartphone. Now this smartphone is connected to the network with the help of a wireless medium. And Tom's device, that is this smartphone, converts the data into waves because the medium is wireless. In both the cases, whether it is a wired medium or a wireless medium, protocols converts the data into signals or waves by appropriately identifying the device to which it is connected to. In this case, Tom's mobile phone, that is the smartphone, converts the data into waves, and after this data is received by this router and it has to forward this to router 1 or router 2. Now this router is connected to router 1 as well as router 2 with the help of a wired medium. The protocol in this router converts these waves into signals. This is what the very important part of a protocol. We will now see what is message formatting and encapsulation. Both the sender and the receiver must mutually agree upon common format so that the communication becomes understandable. At the same time, some encapsulation is also done. With data that it is going to send, this is going to add few more information with the data. That is the source information and the destination information. To be precise, the IP address are added to the data which is going to be sent. Don't worry about this IP address now. We have a separate lecture on IP address. For time being, now take like this. Every human is identified by his name. Likewise, every computer in the network or every device in the network is identified by its IP address. Suppose if this computer wants to send some data, with data, it is going to encapsulate the source IP address and the destination IP address. This source IP address and destination IP address are obviously going to be forwarded through any intermediary devices. When any device receives that packet or data, it knows from where the data is coming and what is the destination. In order to forward the data to the destination, it needs source information and the destination information. This is message formatting and encapsulation. So far we have seen message encoding, message formatting and encapsulation. Now we will see why message timing is to be handled by a protocol. If the sender is very fast and the receiver is a slow receiver, and obviously receiver cannot handle the flow, so there are chances for the data to get lost. To avoid this loss due to high speed sending, flow control has to be ensured by the protocol. That is, in what speed the sender have to send, that information is given to the sender. This information will be provided to the sender by the receiver. It means if this guy can handle 10 data packets at a time, so that information will be sent to the sender. So this sender will start sending 10 packets at a time. This is very important and this is what we call as flow control. And protocols are going to do this flow control. At the same time, after sending the data, the sender will wait for a certain period of time because the time it is waiting in order to receive an acknowledgement. This acknowledgement is really necessary in the network because the sender have to ensure that the data is received by the destination. If the acknowledgement is not received on time, the sender understands that there are some loss and it starts retransmitting that packet or data again so that there is no loss by the receiver. So this flow control and the acknowledgement timing are maintained by protocols in the form of message timing. The next element of the protocol is message size. Let's see an example. We have a very big box to be transported from one building to other. To transport the box, we are given with a very small vehicle. This vehicle can handle very small box but not that big box. What will we do in order to do this transportation? Obviously, we will break the big box into smaller pieces. These pieces can be handled by the vehicle. And each small pieces are transported to the other building, that is the destination. But there is a problem here. There are some chances for the pieces to be missed during transportation. To find it out, we use numbering scheme. That is, when we break the big box into small pieces, we will put numbers on every small box so that the destination can reassemble it in the right way. At the same time, this numbering will also help to identify if any packets or pieces are missing. Likewise, if there is a big file, but the link capacity is small, so the protocol in this computer breaks this big file into smaller segments, and each segment is numbered sequentially. Now these smaller segments can be transported over the network. And this numbering will also help us to identify the missing packets. After receiving all the smaller packets, this receiver will reassemble all the packets. With the help of the numbering, it identifies if there are any missing packets. This is what exactly the message sizing of a protocol. And finally, the message delivery option. Suppose if this guy wants to send exactly to one destination, say for example this web server, then one sender and one receiver. This is an example for Unicast communication. This is unicasting because one sender and one receiver. And the communication can also be multicasting. It means in this network, just see this is one network. And in this network, if this computer is sending data packets to these three computers alone, but not to this printer and voice over IP phone, then this will come under multicasting because there is a sender and group of receivers and not all receivers. This is multicasting. Example, FM radio. If we tune on to that frequency, then only we will receive that signal. Otherwise, we will never receive that. Broadcasting means if this guy is sending some data packet, and everybody in the network will receive that data packet. This is what broadcasting is. One sender, all receiver is called as broadcasting. And now we will see what is peer-to-peer network. In a peer-to-peer network, every node is called as a peer and they are in equal level. It means there is nobody superior and there is nobody inferior. The problem with this is there is nobody in the centralized part to administer the communication. It means whatever rights this guy has, the same kind of rights this guy will also have. And there is no centralized administration. This is suitable for smaller applications, but not for larger applications. And the problem with this scenario is, this peer-to-peer network is, it is not scalable. We have already seen what is scalability in our previous lecture. Scalability means new devices can be added to the network. But this is not a scalable network. Why? Because if this computer has only 2 ports, ports means how many devices it can be connected with. If this computer has 2 ports, then only 2 devices can be connected with. And that is why we call peer-to-peer network is not scalable. Coming to the client-server network, here we will have a centralized administration. And this server is going to do the centralized administration. And all the data will be here. And these are all called slaves and this is going to be the master. In other words, these are all going to be called clients and this is going to be the server. That is why we call this scheme as client-server network. It is also called as request-response model. Say if this guy wants some data from the server, it first gives the request and after accepting the request, the server gives the response, whatever it is requested. And obviously this is a scalable network. Even if 100 devices wants to participate in the network, it can be achieved. But the problem is we are too